Yesterday, on March 6th, 2026, a surprise supercell happened in southwest Michigan. Many models did not have this occurring, and this really produced some pretty big damage there. This is a Menards here. You can see some really big damage there, and unfortunately, there were some fatalities with some of these tornadoes being in a more populated state and with it being harder to see, and again, not really being forecast that well. So I wanted to look into the meteorology of this event, kind of look at the supercell's evolution with time, an example of why this event happened, what was the environment this supercell went into, and things in that sort of regard. So the first thing I want to do is look at the satellite of the day. So this is right now. Let me go back to the time of the event. Here is your morning satellite imagery. This is true color, basically just visible with some actual colors. You can see the ground a little easier. It helps stick it out from in the visible sector. It's really hard to see the ground and what's actually clear air. We had kind of this morning MCS going on over Illinois, and this would slowly stall out with time as it moved eastward. You can see here, there's your outflow boundary with these storms, but for the most part, you can see that the clouds are not really propagating to the east as quickly as maybe some of the models would have expected that day. In particular, when we're watching this little area out here, again, remember there is this kind of gravity wave outflow boundary here, which could produce kind of an area of lifting later on, and you will see that pretty soon right around here. We start to get a few little tiny cells pop up. It's very difficult to see on the satellite, but you can see these little bits of cumulus here that begin to pop up and start to fire. These grew very quickly. I actually have a video I don't show, but this was from campus at Valparaiso because I was still there at the time. You can see very quickly again, within the span of roughly 15 minutes, these all grow into a little cluster here. Let me zoom into the radar because I think the radar here is quite telling. Bad zoom in. Hoping this works. We do have to go backwards in time a little bit, so apologies for that. But yeah, quickly you can see here, you had that quick upscale growth, and quickly you just have one kind of main storm that begins to fire. You can see this more direct cumulus convection there. On the main radar, I can also go back in time here and give you a better view of what that looked like at the time. Again, there is your developing storms out here, kind of in the northwest Indiana portion. Some of these are still in Illinois, but they really begin to cluster here in Lake and Porter counties in Indiana. And very quickly you have one general cluster of storms, which eventually is able to merge, even having a little bit of a hook shape here with some heavier downdrafts. In particular, this is probably the first time where we start to see some broad rotation is this frame right here. Again, I'm going to have to wait for this velocity to work for us. Again, here is your storm once again. You can see a very broad little bit of rotation going on. Let me get the storm relative velocity. That makes life a little bit easier there. I'm going to mess with the radar archive product a little bit. But you do start to get a couplet with time here. It's a little bit messy at first. Let me now move to, we are in the correct radar, perfect. And these are the tornado warnings later on. If we watch this cell right here, you can see it continues to have this couplet. At this point here, you can see again, broad rotation, especially right here over Rolling Prairie at the time. And there's New Carlisle as well. And with time, again, you start to get some cell mergers. Again, remember, this is a few cells all forming at once, kind of along some outflow boundaries. It looks very messy, but there definitely is a good amount of inflow and a pretty healthy storm environment forming here. We'll watch this radar with time, and again, you have that another cell merger in there, goes into the updraft, and very quickly we see a change within the mesocyclone strength. We quickly get this shape here with more cell mergers on the backside, and then you can see again here, much tighter couplet, continues to develop into more of a broader mesocyclone. I'm pretty sure at this point this storm is tornado warned. Before with time here, again, you get that pretty tight couplet right here, kind of near Edwardsburg, and with time this just continues to tighten and give on that really truly supercellular look there, especially with the reflectivity over here. Again, there's your hook, your rear flank downdraft with your foreflank downdraft, and then yeah, just the continued hook echo there. With time, as this would continue to look more and more like a real plain supercell. You can see here again a very classic supercell look. Still a little bit dog-legged, but either way, this tornado was on its way. And I believe at this point you have a confirmed tornado on the ground. At one point here, I believe around the time of this frame, we do get a PDS tornado warning. At least in the time frame around now. And again, you can really see classic hook right there with the forward flank downdraft. So the real question is, what caused this environment to really have a chance at developing? First, I want to look at the RAP model for that day. Now, one thing I have noticed while preparing this video, the RAP model does not give me any soundings. If I try to take a sounding out ahead of the environment, especially with the 9Z run, we are not able to do it. We get a big screen of this sounding will not load, which occasionally happens. So I first want to look at the cams and show you what was going on with them. Basically, especially the her did not have any cells forming outside of this, in front of this line here. This would be right about the time those would form, and we would not get anything in that warm sector in Michigan or anything like that until later on around 3 p.m. And this was, at this point, that tornado has been on the ground and it's done some damage. The NAM nest as well. Again, a little bit of development out ahead, but sometimes it gets very difficult to tell with the NAM nest. It often does not like to... It likes to form a lot of convection, lots of little storms every chance it can get. But again, it does not have a discrete supercell out of the line anywhere here. And actually, it just kind of kills the line entirely, which did not happen in our real-life radar observations. If you go to the 12Z her, we do have a little bit more convection out ahead of the line, I believe, here. Again, this is right at noon, right when those cells are forming. You see a little remnant, maybe some stronger updrafts there. Maybe hinting towards that. But again, this radar look was very different to what we saw here. We still had a lot of convection going on out here over Illinois, while this storm decided to really become supercellular, unlike how the HRRR had here. So really, what I'm saying here is the models were not picking up on this storm in any regard. The synoptic conditions that were able to develop this storm mainly are due to low-level instability. So at the upper levels, or at least the mid-levels here, here's our 500 millibar map at the beginning of the day. We have a broad troughing feature out here, which was able to be supportive of convection out here in Oklahoma, Kansas, and Missouri, as well as parts of Arkansas. Again, if you look at our storm reports, we see some Oklahoma tornadoes, some hail in Nebraska there, and some wind reports in Missouri. Excuse me. Oh, here's your SBC outlook as well. I did want to mention that Michigan was not under any hatched risk, and looking at that damage, most likely that is a significant tornado, if that has not been confirmed already. So again, this is kind of the idea of this was really not expected. Again, there's that failed sounding. So regarding the main synoptic conditions of this event, we had a general troughing feature going on out here over the four corners. This is our 500 millibar map, and this environment was eventually conducive for some more supercellular storms out here, also kind of QLCS events out in eastern Oklahoma and Kansas and parts of Missouri and Arkansas as well. Again, this is with a enhanced risk we had out there for that day, but we're still going to focus on Michigan in particular. Looking down to our surface map, to begin the day, we had a warm front coming into the Midwest, a general low pressure system out here over kind of northern Kansas and Nebraska, which would slowly move to basically right over here throughout the day. We do have this warm front feature beginning over here in Indiana. And a big difference here is this warm front progressed pretty quickly northward. I don't believe this was really expected leading up to this. And if we look back to even a 21Z run the day before, this warm front does get north, but notice the temperatures are a lot lower here between these two models. Here's our 18Z temperatures are sitting right around the mid-50s, and for the actual day, the RAP has us going up into the low 60s even closer and even warmer with time, especially in this little portion of southwest Michigan. Again, this wasn't really forecast very well. It wasn't really in the forecast beforehand. Another main thing to look at is going to be 3 Cape, and that's really the main driver, I believe, for this setup. Now, if we look at our 3 Cape over portions of Indiana and eventually Michigan, with time this is better resolved with later RAP runs. You can see this low-level instability is able to get its way right into Michigan there, right where that storm is firing off. Has at least 100 joules per kilogram of 3 Cape. This environment out here was fairly conducive for strong low-level storms. We didn't really see any fire for the day, but if there had been a forcing mechanism out there, that would have occurred. I also just realized that, yeah, that's going to happen. And I'm going to take a NAM sounding here. Unfortunately, NAM soundings don't particularly they don't exactly look as would be expected. I'm going to take a sounding just to show you what the environment was around the time of the storm in northern Indiana. Um, Again, looking at the 3 Cape, we're going to check out vorticity as well. I do believe that'll be an important factor. Warm fronts have that vorticity, and if we look to our 15Z run right before, basically as close to the initialization as we can get, you do have this good amount of instability going on here in low levels and some bits of vorticity, especially in this region where those storms were able to form right here and eventually track to the northeast. But as long as you have that boundary of vorticity with the supercell, that 3K will be enough to fire your storms. Here is our wind shear environment out there, and you can see the NAM has a lot of 3K, 200 joules per kilogram of 3K, 200. That is a lot of in lower level instability that this storm is ingesting, and you can see, for the most part, a pretty good photograph for what we want to see. We have that low level shear, SRH from 0 to 1 kilometers, 167 meters squared per second squared. That increases to 260 when it gets to up to 3 kilometers in the atmosphere. So a good amount of SRH with this storm. Something you didn't see in most, that you would see in most supercells, is pretty strong winds in the mid levels and aloft to help shunt away a lot of the precip. In the case of our storm, this was pretty low topped, at least from what I can tell. Let me zoom into our sector again as that storm was ongoing. And I believe eventually this thing did have some higher cloud tops, but this may have just generally stayed more as a low-topped cell. You can see eventually you do get that big explosion with time. But for a lot of this storm's life cycle, this was sitting basically in position of, and this is when it has the really classic supercell look that we saw right here. You do that very strong overshooting top very quickly with time there. But either way, with this sounding, the storm was mainly ingesting these low-level winds, which was really strengthening that tornado, helping that really develop that low-level shear and the 850 millibar winds, which help to really spin those supercells when they are firing off at those mesocyclones. So really, the story of today is going to be 3 Cape and vorticity. Oftentimes, this is a pretty classic way of forming a tornado in environments you wouldn't really expect as much. Again, forcing was limited out here. We had some stronger winds aloft. Here's 500 millibars. Some strong winds helping with these storms. 700 millibars. It just wasn't really like a short wave or anything like that was able to broadly develop storms. You look at 250 millibars even, we were still basically under that area of the ridge. So they were definitely missing some of the kinematic components for this supercell, but there was just enough wind overall to force this storm and continue it in its lifetime. Final thing I wanted to do was look at how this storm developed with time and just continue the rest of the radar scan. Again, we ended off here with this very classic supercellular look, but again, you can see here with time, as the storm approaches Three Rivers, basically taking a direct hit on the city and the town here. A very strong couplet, possibly contaminated in some regard, but you can see that's 120 miles per hour of gate to gate shear, basically in that couplet. Granted, this is a good amount of feet above the ground, but either way, you can actually see the debris signature on the reflectivity here pretty quickly as the storm continues to track to the east. And then our secondary region that really was the main headline was Union City over here. The storm will continue to basically ingest little tiny blips on the radar, it looks like, as they went up into either the downdraft or the updraft, which probably also helps to continue this storm's lifetime, but overall also was just a strong supercell that was continuing to develop and basically explode in a pretty prime environment, as we saw. I mean, we saw in that sounding here a good amount of instability as well with the profile, but that shear and the lower level instability, especially the low level instability, was able to really kick-start this storm and make it continue down its path. And then yeah, you can see here again still some strange shapes to the storm with time. It wasn't exactly super duper classic long track because this isn't really in the most favorable supercell environment, but still very favorable and the only storm out here at all for the day. Then you can see as it approaches Union City here again, we do get that radar debris signature once again as it approaches the town right here. This is where a lot of the heaviest damage we see comes from. And again, unfortunately, we don't really have a very close low-level view of this storm. I suppose we could try Detroit. It doesn't look like it makes it out there. Grand Rapids might offer it's going to offer a similar view on the storm as northern Indiana will as well. But this storm did again do some pretty heavy damage overall in these cities we've looked at here. Just being in its own environment like that really helps a storm to continue. This is about the time where our last bits of damage are shown. Again, with time here, let me move forward. The storm begins to kind of die out here. It's not really in as favorable of an environment. Not as discreet, I suppose, here as it was before. You can see some more convection on going around it with time. And also, it's kind of getting closer and closer to that warm front at this point. And you can see they don't issue a tornado warning after this point. The mesocyclone starts to kind of broaden out here a little bit. Granted, we are also a fair amount away from the radar at this point, but the storm, again, begins to dissipate around this time. So that's about all I have for this video. The main things to know about meteorologically is that 3 Cape and vorticity together can be a case for storms like this. Lower level instability was a huge player in this day today. Oh, yesterday, this event that occurred. And there was some aiding in just the general instability profile. Mid-level lapse rates were just a little bit increased compared to other days as well. But yeah, low-level SRH here. Again, you can see the environment was best north of the warm front there. Kind of in the area where you wouldn't expect storms, but they did still manage to occur. And just remembering that in really many environments, when there is that low-level instability, anything can happen when it comes to tornadoes. So again, that's all I have for this video. Thank you for watching, and I will see you next time.